Okay.
Great. Okay, so do you just want to go through the preparation assignment then?
Yeah, let's do that.
All right, I can do the first one. Which hypothesis between the null and alternative hypothesis is the hypothesis of no effect or no difference or status quo or is assumed to be true? Null hypothesis.
Yep. Okay, and does the alternative hypothesis below represent a one-sided or a two-sided alternative hypothesis? And it's one-sided.
Well, fill in the matrix below with the correct responses. Correct decision, type 2 error, type 1 error, correct decision.
Yeah. Define the level of significance in the hypothesis test. With which Greek letter is it? The number to determine if the p-value is small enough to reject the null hypothesis, and the Greek letter is alpha. I don't even know if that made sense or not. So.
Yeah, no, I had a similar thing, so you're good.
Okay, all right.
Write down the formula for computing the test statistic for the hypothesis test for a single mean when sigma is known. I don't know all the words for these, so I'm just gonna say what they look like. Okay. X bar minus, I have no idea, minus u divided by O divided by the square root of n. I know they like it's like standard deviation, whatever they are, but I just
right, yeah. I know. I was like thinking I need to figure out what they all stand for because they say them sometimes.
Yeah.
And I'm like,
I totally forget them though.
Right. Yeah. Define the p-value and how is it used in the hypothesis test. P-value is the probability of getting a test statistic at least as extreme as the one you got, assuming the null hypothesis is true.
Awesome.
And if the p-value is less than the level of significance, we reject the null. And if the p-value is not less, then we fail to reject the null.
Will you say that part one more time? I didn't find that. So how it is used? Will you answer that one more time because I didn't get that part.
If the p-value is less than the level of significance, we reject the null hypothesis. And if the p-value is not less, then we fail to reject the null hypothesis.
Okay, got it. That makes sense. Okay, if the null hypothesis is rejected in the hypothesis test, what is concluded about the alternative hypothesis? I said that we can conclude that the alternative hypothesis is true. It's okay. Okay.
And number 8, it was just way too late. I skipped number 8. So
no worries. You can do it if you want to.
I was doing this at midnight last night, so
Oh, sheesh.
I was like, I'm not even gonna try to think of real life stuff. So
yeah.
Number 9, so the graduate management admissions team is used as an admission criterion in many Masters of Business Administration programs. So the scores on the GMAT and the passive mean score of 529. The BYU professor feels now that the score has improved within the last couple of years. So determine the null and alternative hypothesis. So I said the null, the GMAT mean is 529, and for the alternative, the mean is greater than 529.
And I wrote that too, but how come it's how can we do greater than? Is that just
because he feels that the scores have improved?
Oh, right. Okay.
They're better or greater than.
Okay. Suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam is still 529. Was it type 1 or type 2 error committed? I said type 1. It's okay.
If the analysis was done at a 0.01 level, what is the probability of committing a type 1 error? I couldn't figure out.
That was just 1% because the it's okay. The alpha whatever sigma what is yeah it's the same thing as
so it's the same thing as 1%.
Yeah.
Gotcha.
Oh, yeah. If we wanted to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance? And I said increase.
Right.
Okay.
Mhm. A study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home was an investment rental property. As an investment rental property was 47 years. Assuming the national standard deviation was 5, the real estate agent wants to determine if the average age of those buying investment property in his area is different than the national age. He randomly selected 15 of his clients who purchased an investment property and obtains the value. Design the design. What is the population from which the realtor obtains his data? How did he sample this population? What is the research question? So the population is second home buyers. He randomly selected a sample from his clients. And the question is the national average of second home buyers the same as the average age of his second home buyers in his area?
Okay, collect the data, name at least one way. Oh, I thought it said 2 ways. I was not reading this right. The realtor could have randomly selected a sample. I said using simple random sampling and randomly selecting them through a computer. By sampling and selected every nth person on his client list.
That's what I said. Describe the data, graph the data on a histogram, sketch the histogram below, or cut and paste your electronic copy in a short paragraph. Describe the data by using at least 5 descriptive statistics. So I made a histogram in SPSS and said it was left skewed. The mean was 46.73. The standard deviation is 8.827. The youngest person was 27. The oldest person was 58. My thing said the mode was 38, but
okay.
I don't know.
So I did the minimum, maximum, median, mean, and the first quartile, but I was confused. How do you find the first quartile and the third quartile through like math? Because I read it's like the first half, the right? The median of the first half.
Yeah.
Is the median or the mean of the first half?
Oh, say that again. The median?
The first quartile?
The first quartile is the first 25%.
So how would you figure out, because it said on there that it was 41.5, but I got 42.5, and I don't know what I did wrong.
I usually just do it in SPS, so I don't even remember how you figure.
Oh, really?
Sorry, I don't.
Oh, no, you're good. I was just confused as to what I did or how, but I guess using it's always easier to use the computer than your own brain.
And I do it. I can do it on my calculator too. So
yeah,
now I don't even know the math behind it anymore. So
yeah. Well, some of this stuff I'm like, why do I need to even know this? My major is marriage and family studies. What's your major?
Yeah, that's mine too.
I know this stuff. I really am frustrated that I have to take a math class for it. But oh well.
I guess if we do research and in our area of expertise someday, we would want to know this stuff.
Yeah. Yeah. Okay. D, was it my turn to read? I think it was. Okay, make inference. Check the requirements. Since there are only 50 pieces of data, what will you need to check? I didn't know what they were even asking. I wrote the 5-number summary thinking like you need to check that, but it's just because I wrote something. I don't know, because in the answer key, it gave this whole graph.
Yeah, I wasn't sure either.
I have no idea what it was asking.
The only thing I guess because there's not enough, the data isn't large enough. I wasn't sure either that.
Yeah, no idea. Oh well.
I know. I wasn't sure about that one either because I saw that they did the was it the I can't remember what it was now, but
it was like a plot.
Yeah, that I wasn't sure what we were checking there, but anyways.
No idea.
State the null and alternative hypothesis. null, the mean equals 47. The alternative mean is not equal 47.
I said it was
greater than 47, right?
I think it was not equal because the
47.
yeah, I think you were right the first time.
So is this a two-tailed test?
That's what I said.
Yeah.
Okay, is that alpha side?
Yeah,
Sigma. Yeah. Equal 0.05. Compute the test statistic. What is the formula to be used? Recall our test statistic with will be a z-score. After writing down the general formula, input the numbers you will use. Show this work. Finally, use Excel or calculator to compute your test statistics. So it's the same equation that I said earlier.
Yeah, exactly.
I don't know what I did wrong because I did not get the same answer. I didn't get the same answer. So I think I must have put the wrong numbers in.
No, I didn't get the same answer either. What did you get?
I got 0.162.
I got 0.118.
So what numbers did you put in? I did 47, right? Is that you did 47 minus 46.73. That's what I did.
I did 46.73 minus 47. Divided by, what was your standard deviation?
I thought it was 5 from question 10. It says standard deviation was 5.
Well, but you have to figure out the standard deviation with the 15.
Okay, then that's what I did wrong then.
Right? So you have to do 5,
Yeah.
5 divided by the square root of 15.
Which is
Yeah. But
1.6, right?
Well, but I just did it in the spreadsheet that we have.
But then I thought, so well, the equation that I did was 40. I know that I put numbers in wrong. I had 47 minus 46.73 divided by 5 divided by the square root of 15.
Okay, so now that I'm looking at that standard deviation is not right. So
To find that, you do 5 divided by the square root of 15, right?
right.
Is that what you're saying?
Yeah.
I got 1.666.
Okay, so I'm going to plug this in to the 1.291.
Let me see what I did wrong. Oh, I know what I did. Okay. I know what I did.
Now I got negative 2.09.
So what was the equation that you did then?
Okay, so 46.73 minus 47 divided by 1.291 divided by the square root of 15.
Okay, that makes sense then.
Yeah, equals a negative 0.290.
And that's what, so I must have exited out of it. And that's what it says on, is that what it says on the sheet? Let's see.
They got negative 0.207.
I think it's close enough. You
Yeah.
said you had negative 2.09.
Yeah.
Negative 2.09 or negative 0.209?
Negative 0.209.
Okay. Okay. I think that's close enough.
then we're looking for the areas between, right?
Mm-hmm. Let's see. So for this one, I didn't understand this either. This one you use the applet.
Right.
Well, it says sketch a normal curve. I didn't do that. Graph your test statistic along the horizontal axis. Shade the appropriate under the curve. Use the normal applet to compute the area under the curve. This area is p-value. So you would select the left side of it, right?
What do we do? Oh, we're doing the outsides, right?
Uh-huh.
So, oops, wrong one. There is, okay, there's an applet that you can use that you can actually figure out the outsides.
Oh, really?
Yeah. I'll email you the link here, just 1 second, right? 8.834. This one actually does a lot more than that. Applet that we, wait, is this that one? That doesn't seem, hold on. I wonder why it does that. It's a really weird. Oh, because I'm doing it from a link off my desktop.
Oh.
Let me think about this. How can I get this to you? Okay, I have it now. Okay. I have so many things open. I can't think. Okay, so here's the, okay, so I've emailed you the link. So
Okay. Let's see. There we go. Yes, I got it.
Okay.
Oh, it says a lot more.
Yeah.
Okay.
So then you click the one that says area from a value,
Uh-huh.
and it should say like specify parameters. It says mean, standard deviation. The mean
Right. Uh-huh.
0, the standard deviation should be 1.
Uh-huh.
So then if you click on the outside, because we were looking for the outside, and you put in your negative 0.209 and then 0.209. And then your probability shows up down below.
0.4191.
Click,
Oh, I messed up.
Click recalculate. Yeah. Make sure you have
0.834.
Yeah. Yeah.
Perfect.
So anytime you want to figure out probability, you click that area from a value. And then the other one is if you want to know your z-score.
Okay, this tells a lot more than that other one.
Mm-hmm. Yeah.
Okay. So compare the p-value to the level of significance. Do you reject the null hypothesis or fail to reject the null? Fail to reject the null.
Yep. So then state your conclusion in terms of the alternative hypothesis. We don't have enough evidence to conclude the average is different in this area than the national average. So we cannot confirm the alternative hypothesis.
Okay. And then what action, if any, do you suggest the realtor to take based on your statistical conclusions? Keep on testing, same age of people or same group of, yeah. That's what I wrote.
Right.
Awesome. Okay, now we can do the quiz. Okay. Okay. Are you there?
Yep.
Okay. Which hypothesis involves equality? The alternative hypothesis?
No, because it involves greater than, less than, or
I thought the alternative was equals or doesn't equal.
nope, greater than, less than, or not equal to.
Oh, so would it be the null hypothesis?
Well,
Let me see. So with our at the beginning of the preparation, it shows on question 2, the alternative hypothesis is equals 0 or is greater than 0. Wait, does 8, no. Wait, okay. I think the top one, H, whatever the O stands for.
yeah, I think it's the null hypothesis.
I think it is too. Okay.
All right, p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was, okay, repeat. When computing the p-value, which hypothesis do you assume to be true? Wait.
Null, I think. Don't you most of the time assume the hypothesis to be the null hypothesis to be true, and then if it's not, then you go to the alternative?
But when you're computing the p-value, that's for the alternative hypothesis, right? But I think you're right. We're always assuming that the null hypothesis is true.
I don't know. At least we have 2 tries.
Yeah. Go with the null hypothesis. Go with the null,
Yeah.
and if we're wrong, we're going to go back and do the alternative.
Yeah.
Okay.
You suppose the null hypothesis is 10. Use this information to answer next 2 questions. Which of the following represents the alternative hypothesis for a 2-tailed test? Does not equal 10?
Correct. is which the following represents the alternative hypothesis for left-tailed test is greater than 10, I believe.
Mhm. Okay, which of the following represents the alternative hypothesis for a right-tailed test? Less than?
I believe so. Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or alpha. Use this information to ask questions. Which relationship will result in failing to reject the null hypothesis?
You wrote it down in this.
P-value would be greater than alpha.
Failing to reject. So it doesn't say they can be used to determine if the p-value is small enough to reject the null hypothesis. But failing to reject, yeah, greater than. Is that what you just said?
Yeah.
Sorry, I'm like thinking out loud.
Is that right? What did you say?
I think it's greater than. I was reading something that we had written down for number 4, but it was saying to reject, but we're doing failing to reject. So it would be greater than. If it was less than, then it would reject, right?
Yeah, hopefully I wrote that
Pretty
down.
sure. I think
Hopefully I wrote it down right.
well, I wrote that too. So I think we got it. So greater than.
Okay. Which relationship result in rejecting the null hypothesis? So the p-value is less than?
Sigma or alpha, yeah.
Yeah.
Okay, an insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this information for the next 2 questions. Which of the following would be the appropriate alternative hypothesis? H alpha. So they are concerned that the true mean is actually higher than this. So it's less, the average, would it be the average claim amount is less than 1,500?
They're concerned that the true mean is higher.
Uh-huh.
So if the average, so that would be greater than, right?
But it's saying the alternative. Isn't this the null what they're saying up in the top? When originally setting the rates, they believed the average claim amount was $1,500.
If the average
They're
claim
concerned the true mean is actually.
so if they're saying the average is 1,500, but the true mean is higher, it's greater than 1,500.
But is that the appropriate alternative hypothesis? I don't know. I'm not trying to prove you wrong. I'm just wondering. I don't get it.
Oh, I see what you mean. So if we're going to prove that it's.
Because the next question is, what would be the appropriate null hypothesis?
Well, the appropriate is average claim is equal to 1,500.
So would the appropriate alternative be that it's not equal to 1,500?
Yeah, I guess so.
I don't know.
I'm not really, because yeah, I'm not really sure how you determine, to be honest with you, how to determine alternatives. So
Yeah, I don't really know
not
either.
equal to, sounds good to me. The insurance company randomly selects 40 claims and calculates a sample mean of 1,650. Use this information to answer the next 3 questions. The insurance company assumes the distribution sample mean is normal. Is this a good assumption? It is a good assumption since the sample size is large. It's not a good assumption since the sample size is small. It is a good assumption since the population is normal. It's a good assumption since the population is not normal. It is a good assumption since the sample size is large.
Great, I agree. What theorem or law justifies your answer to the previous question? Central limit theorem.
Yep. Which of the following is the test statistic as defined in this lesson?
Isn't it X bar?
I don't remember, so I'm going to agree with you.
I think it is. I mean, I think that Z is Z score.
Yeah.
N is the
Sample,
sample.
right?
Don't know what S is.
I don't either.
I think, yeah, let's just do X bar. I think that's right.
Sounds good to me. Go ahead.
All right, the historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with a hypothesis. What is that U? I want to know what the word is, but I just really don't know. Equals $150. What is it?
I don't know either, yeah. I just know it stands for mean.
Okay, I'll just say mean. Equals $150 or is less than. She'll use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes X bar equals $144. Use this information to answer the next 4 questions. What is the Z-score associated with this test? Round to the 3 decimal places. Okay. So we need to do the standard, is this, well.
So standard deviation is 40.
Divided by the square root of this sample, right?
Mm-hmm.
Where's the sample?
Random sample of 36.
36. So 40 divided by 6, right?
40 divided by 30.
I think that. But isn't it the square root of 36?
Oh, correct, yes.
I think that's 6, right? Square root of 36?
I believe so. I'm using the spreadsheet, so.
Okay, yeah. I got 6.666.
Hold on one second.
Okay.
Got what?
6.667.
Yep.
Okay, great.
So the Z-score then is.
So wait, so what was it that we just figured out with that? I thought that was
That was the standard deviation. So you figure out the Z-score.
okay.
And then a negative 0.9.
Did you put that into did you put that into the normal applet?
No, there's he had a spreadsheet, an Excel
Oh,
spreadsheet,
okay.
the formula in it.
Okay. Let me see, I lost my negative 0.9 is what you said?
Yeah, negative 0.900. When it says round to 3 decimal places, when you put your answers in, do you put the zeros?
You mean like the zeros at the end of it, like negative 0.900?
Yeah.
I mean, this is the first time I've had to do it. I don't think I've had them end in zeros before. I think I will. I don't know.
I know, exactly.
Okay, so what is the p-value associated with the z-score from the previous question? I do not have any idea how to find that.
did they show us how to figure out p-value?
Maybe
Oh, wait.
in our,
Yeah, shade. It's the, so yeah, this is the probability. So go to the applet. This one. And the p-value is, so what was our hypothesis? We went less than, so we went to the left, so we went below. So the z-score was, what did I say? Negative point.
negative 0.900.
So 0.184.
That's what I, okay, do you want to do number 17?
Okay, so what inference would you make about the null hypothesis for this problem? So 0.184 is greater than,
So you'd fail to,
so it failed to reject the null hypothesis.
okay. So what is your conclusion for this problem? We have insufficient evidence that the true population mean is 150. We have sufficient evidence that the true population mean is 150. We have insufficient evidence that the true population mean is less than 150, and we have sufficient evidence that the true population mean is less than 150. So they're trying to prove. So would it be we have insufficient evidence that the true population mean is 150? So we're not trying to prove that it's less than, are we? We're trying to prove that it is or isn't 150.
Right.
So I don't think that we have sufficient evidence, but I am guessing. So because since we're failing to reject, I don't know.
Jeez. This is where I get all mixed up with this hypothesis.
Yeah.
Well,
But maybe we do have sufficient evidence that the true population mean is 150 because we're not rejecting the null hypothesis. And the null hypothesis is that, where did it go? The null hypothesis is that, shoot, what am I looking at? I don't know.
well, I mean, we have insufficient evidence that it's less than 150.
Just put that and then just see what we get. Is that right?
Yeah.
Go through it again. Okay. Okay. Number 19. You want to read this one?
There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? Oh, I forget.
I think it's type 1. Because on our preparation assignment, on 9B, suppose you had evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam is still 529. And the answer was type 1. Okay. So when you reject the null hypothesis when it's actually true.
Okay, sounds good.
Okay, the researcher decided that instead of using level of significance of alpha equals 0.05, you'll use alpha equals 0.01, which of the following will be true. The probability of a type 1 error will increase. Type 2 error will increase. The null hypothesis is true will decrease, or his experiments will be more scientifically valid. I think that type 2 error or type 1 error will increase. So when, actually, I know when the type, right, when type 1 error gets bigger, type 2 decreases.
Right.
Type 2 error will increase because it will decrease if it gets, well, wait, but it's getting smaller though, right? No, wait, why? I am confused. I am so confused.
Oh no. Oh.
So if it's 0.05 and it goes to 0.01, it's getting smaller, right? Because 0.01 is 1 per, or 0.1, oh my goodness, percent.
Right.
Or 1%. And before it was 5%. So it is getting smaller.
Right.
So type 2 error will increase, right? Because if it's getting bigger, it'll decrease. Because on 9D, if we want to decrease the probability of making a type 2 error, or decrease the level of significance. And the answer was to increase. So if we want to decrease type 2, you need to increase. We're decreasing type 1, which would in turn increase type 2. I feel like I'm just saying a tongue twister right now. I think type 2 error will increase from this.
Type 2 error will increase, you think?
I think so. Alpha, or the level of significance, which is the alpha thing, is going from 0.05 to 0.01. Okay. So it's getting smaller.
I think you're right.
Right? Okay. Okay. Do you want to do 21? Or read 21?
And if alpha equals 0.05, compute the probability of committing a type 1 error.
I have no idea. Wait, I guess it would just be, I know, I have no idea actually. I was thinking that isn't the level of significance, but that's not the same thing. It's asking for the probability committing a type 1 error. No, actually, it would be, so like on, I'm just using the preparation thing. On 9C, it says if the analysis was done at alpha equals 0.01, what is the probability of committing a type 1 error? And it was 1%. So would this still be, it's round to 2 decimal places, wouldn't it still be 0.05?
Point 0.05%, you think?
Yeah, because on 9C, it says the exact same question, and the answer was
1%.
Still 1%. So 0.01, which is the same thing as the level of significance, or alpha. I could be wrong, but if we're following the same as 9C, it's the exact same answer.
Right. Right. So 0.05.
Uh-huh. Sheesh, this is a ridiculous
Yeah.
Okay, let's just see what we've got, and then we can go through it again if we
Yeah.
go. So we got question number 6 and 7 wrong. 6 and 7 wrong. Question number 10 wrong. Question number 14 wrong. Oh man. Hey, but we got the last ones right.
Yeah.
That's pretty good. I mean,
Yeah,
you
considering.
didn't get too many wrong.
Okay, so let me get.
So we can go through these again. I'm just opening up another tab so I can see what answers we already put in there.
Okay.
So we can just, all the right answers that we've already gotten, we can just,
Yeah.
you know. Well, I think we did pretty good for
Yeah.
having it be so difficult.
Yeah, exactly.
Okay, so for number 3, we got that right, and we put the null hypothesis. Number 4, whoops, sheesh. We put the null hypothesis and got right. 5, we got right also, does not equal 10. Number 6, we did not get right. So which of the following represents the alternative hypothesis for a left-tailed test? I have no idea what that even means. You know what, actually, if it's left-tailed, that means it's going to be less.
Less than. Yeah, for sure. Huh.
We both thought of that wrong. We were both thinking. And then the next one will be greater than. Because we got that one wrong too.
Yeah, we just totally did that backwards.
How funny. Okay, less than and then greater than.
Yeah.
For 7, right?
Yeah.
Okay, for 8, we got that right. Greater than alpha. 9, we got right. Less than alpha. 10, we got wrong.
Okay.
So we said the average claim amount is not equal to 1,500 for the alternative. I think it's less than 1,500. But
I still think it's high. I think it's greater than, because she's thinking that it's higher, like that it's more than 1,500. That the true mean is actually more than 1,500.
oh, so she's kind of stating the null and alternative in her,
Yeah.
in what she's saying, in what it's saying.
Yeah.
That makes sense. So greater than. And then the null hypothesis, we got that right, is equal to 1,500. 12, we got right. Sample size is large. 13, we got right. Central limit theorem. Okay, 14, we got wrong. And I have no idea.
Okay. I have the lesson.
I think it's got to be X.
I have the
But
lesson open, so let me do a quick search.
okay.
Test. Assuming the hypothesis is true, we assume the true mean body temperature of healthy adults actually is the mean. Wanting to test this claim, researchers collected data on the mean body temperatures of N. So that was X bar. Since we know this innovation is the case, we can use the z-score to determine if X bar is far from the assumed value. This is called the test statistics.
X bar?
Z.
That's what you put.
No. Z. The
Z
score.
Oh, funny. That was one that I was like, sure, it wasn't. But okay.
Okay. Okay.
We got number 15, right? Negative 0.9. Whoops. Okay, we got number 16 right, which is 0.184. 17 we got right, it just failed to reject. 18 we got right. We have sufficient evidence that the true population mean is 150.
We have insufficient evidence.
We have sufficient evidence. So this, for me, it was the second one. Number 19, type 1.
Wait, it was, wait, hold on. Number 18?
Number 18 is we have sufficient evidence that the true population mean is 150.
We have insufficient evidence.
Is that what? I thought we have sufficient evidence, and I got it right.
You put what?
Sufficient.
Oh, I put we have insufficient evidence that the true population is less than 150, and I got it right.
You know what? I must have accidentally clicked on it because you can click on different answers. So you know what? You're probably right. You're probably right. I think I accidentally clicked on it. You know, afterwards, you can click on different answers.
Oh, you can?
I think I must have accidentally clicked on it, not to get it right or not, but I think I was just clicking. I must have clicked on it wrong. So you probably have it because I'm positive I must have clicked it. So you said we have insufficient evidence that the true population mean is
less than 150. Less than 150.
Okay, I think you had it right.
I hope I didn't click on something.
No, I remember us putting that one. I
didn't know you can click on different answers.
I didn't until doing this quiz and realizing that I Okay, 19, type 1. 20, type 2 error will increase. And 21, 0.05. Let's see. Yeah, we got 100%.
Nice.
Awesome. Cool. Well, great. We can meet next week then on Tuesday.
Yeah, that will work.
Sounds good. We'll have a good week. Hopefully it's not too stressful.
Yeah, no, I think once I get a few more things done, I'll be doing great. So, you too.
All right, well, I'll talk to you on Tuesday.
Okay, sounds good.
Mm-hmm.
Bye.